again, keep this test, use it to study with. You're gonna see a lot of these questions come back on the final in a few weeks. But also know that I do dig around, I paw around in the test guides, CFA test guides, so you may see CFA test questions. Now they use, I want to tell you that the new testing system, one of the things that they're doing is that they want you to be able to interpolate charts. So if any of you use the wire chart for electricity, the electrical class for gauging wire, runs the wire. We have a really long piece of wire, you gotta gauge up a little bit. In order to get a shorter one, you gauge down just a little bit. So if you use that, that's the kind of thing they're talking about there. So when you look at the charts that are presented to you, and I don't know which ones they are, you may see charts for almost anything. Aluminum, maybe you have to gauge up for some aluminum, hydraulic tubing, depending on the run, or the wall thickness, any of that kind of stuff. Plan on being able to interpolate that chart. Take both the left and the right, and the line means that's what you're looking at. But there may not be a number there for you. So you're going to have to figure out where that number falls between the two. Something else I was going to, oh, there's some more helicopter questions about to show up after June 1st. Some helicopter aerodynamics, so go back and look in your books, dig back in there a little bit. I'm not going to go back in and do a review for you, but I want you to know that you should probably spend a little extra time looking at that stuff. Also, maintenance entries. Make sure you can do a maintenance entry. Make sure you can do a 337. And there was one other thing that they are ramping up a little bit. No, they didn't take this silk and fabric out, but
You take wood out?
take the what?
Wood?
Wood, no, the wood's still in there. Make sure that, so make sure, there's a chart for that too, for rise and loss on the grain. So make sure that you guys can read this stuff and get yourself up to speed when you finally do go take your test. Go, for gosh sakes, go take that test as quick as you can, because there's not going to be any time that you aren't going to be better suited to take it. Most everybody that I've talked to that spent a couple of days in the test guide went and took their writtens, and then they spent a couple of days kind of boning up, maybe on what they were a little bit weak with the examiner, because the examiner is going to take your written test scores, he's going to look at them, and then he's going to see how you do with those. And if you still can't answer those same questions, he's going to probably put his spurs on and ride you a little bit. You can answer them, it's going to be a walk in the park. So, well, okay, so it's not a walk in the park, but because you'd be all nervous and excited and all that. But our students typically come back and say it wasn't as bad as they thought it was going to be. So, so know that that's out there waiting for you too. So let's take a little break. Take 15 minutes. Come back at 22, and we'll get started on some ignition systems.
We also need to talk about written.
Oh, let's do that now. Let's do that right now. Somebody get your syllabus or your course record sheet out. Somebody's got one laying there. One by one. Everybody, just get a piece of paper. You don't have to write it down. Just write what you need and what you don't need, because some of these I'm not going to make you do. Okay, what's the first one?
Notebook.
Notebook.
Don't need it? Got it.
Don't need it.
Don't need it.
What? Look at those surprises. Look at surprise faces. I'm not
You're
gonna.
taking all these notes for
I'm
nothing?
not. For nothing? Nothing? What was your score?
You gotta ask Landon.
Yeah, 'cause he ain't talking. So I'm not gonna make you do a notebook for this class, all right? But I want you to keep some notes. So these other writtens that I'm gonna have you do, I want you to put a bulldog clip on. This is a big class. When I have a class of like 20 or something, I'll make them all do notebooks, because you guys are all off, you're all off water skiing and horseback riding and doing whatever it is you do to have fun. And I'm gonna be sitting on my floor in my apartment with my Guinness. And I'm gonna be looking at freaking notebooks for like the rest of my life, right? So that ain't gonna happen. So I just wanna look at your risks. What's number 2 there, Brian?
Number 2 is diagram and describe the operation of a FADEX system, first time turbine engine. Include all input sensors and how each sensor is used.
Cross out 2.
Okay.
Cross out 2.
3,
There's so many different FADEX systems. Usually what I do is I give a typical, I'll do this in class probably. I'll give you a typical layout of the sensors that are involved in the electronic engine controls. But every one of them uses something different. And what I want you to know is that they use a number of different sensors, and they are typically standard sensors that are used in all the FADEX systems. But every manufacturer's got some other little particular things that they're looking for. So we're looking for rotor speeds, we're looking for inlet air temperatures. Any of you ever see that little thing, looks like a pitot tube on the inlet? Yeah, a pitot tube on the inlet. Well, what that does, that measures the air mass and also the temperature. Now, that's pretty important. And so some of you have had Wheeler's patented induction and fuel metering class, right? Now, what does the injection system look for on those engines? What does it measure? What does it physically
mass.
measure?
Yeah.
What is it?
Air mass.
Air mass, right? And so air mass and temperature, are they tied together? Inexplicably tied together. So that's why that thing hangs on the inlet. A lot of times you go to the airport and you're waiting for your flight. Look at the inlet of the airplane. It's going to be something that looks like a pitot tube up there. Well, that's in fact what it is. Of course, we don't call it that. We call it P2T tube, pressure tube and temperature tube. They're both picked off at the same place. Then as you go further back, you want to know what the rotor speeds are. You want to know what the pressures are throughout the engine and so forth. You want to know what the temperatures are. What temperature does the air leave the compressor at? So on and so forth. So I'm going to talk about all that stuff, but most of this is pretty standard stuff. But every engine manufacturer pulls it off in a different way or may use different terminology for it. And that's why I don't want you to have to go pawing around in there. Because one of you is going to get into one of the new geared turbo fans. They don't call anything like what anybody else calls it ever before. They have new terminology, so new technology, and so they call it something different. So one of you rascals will do that, and I'll be just sitting there, I'll have to have an extra drink of Guinness. I gotta go look at it. Okay, what's the next one you got there, Brian?
diagram and explain in your own words the operation of the gas turbine engine.
That's a pretty easy one. You all should be able to do that. Pretty easy. You should be able to do that.
What number is that?
3.
Okay. 4th one, explain in writing the relationships of RPM, fuel flow, airflow, and thrust to one another in a gas turbine.
Okay, you all can do that. 4, right?
If you don't want us to, though, I don't argue with
No, I gotta have you do something.
it. We already did, so we're doing number 3.
All right, so we're doing 3, now we're doing 4.
Alright. 5, identify and explain in writing in detail one type of turbine pneumatic system.
Pneumatic system, so I'm gonna maybe talk about this today, maybe not. I'm gonna talk about anti-ice and cooling and that sort of thing. But, so what have we talked about so far that is another pneumatic system?
Starter.
Starter, yeah, so you're welcome to use that, sure. And there's some other systems that you can get into. And that's fine. What's the next one you got?
Final exam.
Final exam, we'll all
Can we
do
skip
that.
that? That's optional. Can we skip that?
So what I want you to do is take those sheets of paper and put a bulldog clip on them and make them look nice, because I want you to do your best work. Don't just look like you did them 5 minutes before.
3, 4, and 5.
So that's what I want you to do.
This is bold
Yeah.
on clip you're talking about.
What he said.
Big clip.
Bulldog clip, what is that?
Oh,
Paper clip.
it's one of these right here, little binder clip. Yeah, just put a clip on it, that way I can take it apart if I need to. And that way all the papers stay together.
Are you supplying this?
I want you all to chip in 5 cents a piece, and you can buy yourself a box of it. Make sense for 100?
Because the store doesn't.
Okay, so I'm gonna let you guys handle that. Now, I have to say this, so 3 people last semester, they were all kind of working together. You guys are welcome to work together on stuff, I don't care. You're welcome to make trade things, but because I'm no artist, and that's okay. But when you do a tracing, tell me where you got it from. And when you do some written work, tell me if you stole it, ripped it right off the page or not, because I kind of know how you all talk, you know. And some of this sounded like somebody's doctoral dissertation. And so I usually what I do, I should tell you this, is I go to Google and I type in some lines, maybe only a few words, just because of the way it's phrased. And I go, oh, it is somebody's dissertation. Well, this guy wanted to graduate. Zero credit on this work. And so, so he didn't get to graduate. He was all pissed off, angry, and said, you can't do that to me. I said, well, you stolen this from somebody else. So be sure that when you do this work, go ahead and read it. If you understand it, paraphrase it, that's good. But I want to see that you understand it. If you don't understand it, and it looks kind of hinky to me, I'm going to do that Google search. But God damn, if it doesn't show up, you know, you can take almost anything that's written and do a Google search. I'm going to find it. So please use your terminology, use your intellect, because at some point down the road you're going to have to tell somebody how things work. You're going to have to tell them what you're thinking, and if it didn't sound right, it ain't going to sound right.
Well, you can quote stuff too, right? As long as you give them the credit. You do a proper quotation.
Yeah, but I don't want you to do that for the whole thing.
Not the whole thing, but I'm saying take pieces of it.
Yeah, if you want to take a paragraph or something that's really kind of wordy, go ahead and do that. That's okay, as long as you attribute where you got it from, right? But then just don't keep going with it, saying, yeah, I did the rest of it. Yeah, me and Cyril here wrote this little story, and I give Cyril credit for this much, but actually Cyril wrote this much, and you're claiming the rest of it. So be real careful, because I do check this stuff. 3 guys, and it was a turbines class and a props class last semester. I don't know why they do that. You start getting your back to the wall, because you got plenty of time to get this stuff done now. Go get yourself a burrito on your break. Sit down at the table out here, and you can do your paperwork and get it all done. Nobody's here to bother you. Get it all done. It's over with. That's all there is to it. But you know, if you want to go hang out at the bar and then work on this later on, then you kind of put your back in the corner, and I don't want you to see it after Sunday. Because you can't be falsely making entries on documents on aircraft, and I don't want you to get into the habit of copying stuff. Right? If you go to a book, you're going to use the exact phrases out of a book, because that is your authority to do the work. That's fine, and everybody understands that. If you have to write a report somewhere, it better darn well be your words, because somebody's going to figure you out real quick. So I know how Brian talks, I know how Elaine talks, I know how McGott talks, and Ford and all the rest of you. And if you come off sounding like you're in a minister of Parliament, I'll pin your ears back. I'll do it real quick. And I don't even have to say anything. You'll have all summer, you'll be thinking, I'm fat, I'm unhappy, and come back here and go, what the hell? It's going to be on you. So don't plagiarize. Just don't do it. Because I catch somebody every single time. I not only have the Guinness, but I also have my laptop sitting there. Okay, so now let's go take a little break. Come back at 10 till, and we'll continue on again.
Kick this real good, man.
Basically, he referenced the sensor, the CT range for the swing, 43 pounds, and
I usually use, and I usually use the forward range, because anything you put in the airplane is going to be range. I have you use the front of the range all the time, and that makes sense. You don't have any calculations.
The 40 then? No, you want me to go with the,
Whatever is the furthest forward.
okay.
Yep.
Or furthest forward, so that'd be 30. For max weight, though? Max weight is 40, this one would be for max weight.
Well, I just want you to use the empty weight because, you could put a pilot in there, you might not put two pilots in there, you might put one, all of that's gonna change. The only thing we have to worry about is the propeller installation on the engine, and that's gonna be part of the empty weight CG of the air.
So I'll go with the 33 then, or,
Go with a 33.
the other issue I had was that, so I found a pilot operating aircraft that had a spinner weight, I think probably the old one, but an empty propeller, they only needed the weight for the assembly of the spinner and prop. So that's why this one has both, but the new one doesn't.
So when you take one off, you're gonna have to remove the weight, and then you can just add just this one. Instead of adding all the other stuff.
Exactly, I was going to explain, make sure, cause, I did it with, Mark.
Yep, yep, good.
I just wanted to make sure that was fine, and then other than that, I did my, sorry. I just wanted to make sure that I have everything properly so I can print it out for you. And then so for the 337 form, everything, all of that stuff, I did break the
Roll it
weights.
back up. Okay, roll it up slowly.
That was the first
Yeah,
one.
you can get rid of, you don't even have to split that.
So it was, this, put everything down the way, but this is for me doing the work, correct? So I put that, and then what you said here, I included my, maintenance logs here, but I know you don't put it separately.
Yeah, just do a Word document page, so I have to do.
But, pretty much just this stuff, up to this point.
So you have some reference to the new weight and balance on
Yes, the.
it? Oh, okay,
weight
updated
balance.
reflects its alteration, okay. And what that should, there should be another line attached to that that says, see, updated weight and balance and state.
Okay. I'll add that after.
That ties the two together.
And then put inspector quality for integrity at each 100-hour or annual.
It's part of the, updated instructions, yeah.
And then, I just had kind of been updating the STC.
Good.
So,
You look like you're going good so far.
so,
So you're gonna have a weight and balance computation in there you're gonna have to do,
which was, that.
which is that. Is there any range marking changes on the instruments? You'll find that in the SDC document.
No, so, they didn't include any benchmarking, so they said that, performance was going to increase miles per gallon. And then, also, it was going to be, lightweight. So when I did my computation, I only had like a 12-pound difference.
Yeah. Yeah, well, that's okay, it's okay. Sometimes they change the,
But it didn't, it didn't.
change the tachometer reading, sometimes they change the manifold pressure reading and so forth, so if you don't have to do that, you could.
So as long as it's perfect, then,
Yep.
uh,
And then you need a century on there, you should be good.
which is this one, right? Just,
Yeah, but that doesn't go, you can take that off of your, off of this page, because it's a 337. Just make a separate page, it's a maintenance entry.
okay, thank you.
So this is gonna explain what you did, all of this, right?
Yes.
Okay, so then compliance, okay, good. Okay, so you basically said this again throughout here.
Exactly.
So, so take in, you can take this one off, this is your maintenance page right here, put all that in a separate place.
Okay, great, thank you. The bushing.
Yeah. Yeah, you're gonna have to, if you're not feeling it.
You know, the thing with the Best Boys that I like is that their drop rate is so low. So I ended up with a lot of like Best Boy wings and shells and stuff.
Since their drop rate is so low, then if they shouldn't be dropping a lot of stuff.
That's what I'm saying, like 1 out of every 10 was
It's just because
dying.
it's just because the weapon you use, like now, like with my insect blade, I just shoot, I don't know how building you can shoot them and stuff.
Yeah.
I just shoot them down with parallax and stuff, and so they just eventually die, and their bodies don't get destroyed. Cause I'm not showing them. Smart and harder.
I don't have such a weak weapon though.
Thank you for the cookies, Jake.
Jake's cookies. Did you make those or did your mom make those? You
I could taste the love, man. Appreciate it. Yeah. I appreciate you. Let you know that.
There's cookies.
Nobody wants your cookies, Jake. Nobody.
Because I've never seen Jake wash his hands. She almost put it back. She's like, have I ever seen him wash his hands? Somebody gonna go through the receipts once too, and I can cut back some of those too.
You wanna do it? Great.
damn, that was fast. I was like, yeah, I can fall crash every time. Okay.
What's up with that offer?
She's still there.
It's still there.
I mean, she went down once because like,
Is it?
The whole time.
Oh yeah.
I read Suko, it's like a red panda that works, day shift, like an assistant job. Well, then like, seems
They wouldn't developing any oil pressure.
oh
Dude, I just started watching it, and she put me on
Actually, I
it.
guess.
Yeah, I just like that introduction
Is that there, like-
where like
Yeah.
he's talking about it, like,
I don't know what it was.
Dude, it's actually really worth it.
Yeah, it's just burning the oil and everything.
It's like this nice like.
Completely drained
yeah, that's
for
what I'm saying.
shipping.
It's like, this is
When they shipped it
It's
over
like
here,
super quiet and stuff, but it's like full of moisture.
got an air bubble trap in it. So the standpipe
It's like noise,
had
you know, you don't know when they're
Or the
gonna erupt.
suction
The
tube.
noise just leaks
So
out.
the oil pickup had a bubble in it, so the pump couldn't pull it.
That's easy. Sorry, more than that.
No, is that, so the purchase.
So they finally got to develop oil pressure by turning it. Started.
All of our measurements.
Keeps to run around.
Did you get a taxi up there?
Contacts are there. They were RG.
Yeah.
I actually was there like the hangar a couple days after they got it.
Oh, the,
I had to move it, put the tube back in. So I got to check it out right after they got it. I wonder if they fixed the starter solenoid on the Duke. Probably not,
Probably not.
because the left engine won't start.
Probably didn't do anything to it.
I ran the right engine, but the left engine, the starter solenoid, someone arced it, burnt it, so it won't start. The left will, or the right will. Just because you normally start the left and then you start the right, the left won't do anything. The right runs. The thing has no brakes anyway, so I couldn't taxi it.
That's right, it doesn't like civic break.
So I may eventually. I think. It depends. Maybe next Friday I may go down to the hangar while the class is down there, while Lyle's down there, and hang out and work on the Duke while Lyle's there, just for kicks and giggles.
There you go.
Bleed the brakes.
Got something to do.
That way I can play with it. I like that thing, man.
Yeah. That's pretty
Damn.
fun, you know?
The thing is like that thing was so well taken care of by the previous owners. If they knew how dirty it was, like a water spot would freak them out. That thing was freaking out. But
What happens when you
they donated it.
donate to the school?
Well, I told you why they donated it to school, right?
Because they think about the price of.
Well, it's because Bill Black, you know, who is a real estate developer in La Jolla, he's what Black's Beach is named after.
Right.
Bill Black and a guy named Shaker Razuk owned it, and they were both multimillionaires. And so it was too much of a financial risk to sell the plane
Yeah.
because someone would buy it and crash it just so they could sue them.
Yeah.
So instead, they donated it to the school.
Yeah. That's right.
Because if they-
Flown again.
Right. But if the school were to sell it,
And then something-
then it's on the school.
Yeah.
Exactly. So you know you're buying the thing as is, and therefore there's no way to get back to Bill and Shaker.
Huh.
You're not gonna enjoy it.
And then after you like that, we're gonna go where?
But that's only 10 minutes out of our lunch break. And that shit was like this big and like this round. I'm like, how the fuck am I supposed to eat like 6 of those? That shit was packed with rice.
I know, that's why they get you.
That's
That's
how
how
they
they get
get
you.
you.
Yeah, how they get
They
you.
don't know, man. They don't know. I tried
You
some
know.
of those challenges, bro.
Cool. Yeah, go real fast.
I think I told you guys, like, you used to weigh 350 pounds, bro. I tried some of them challenges. I tried to, I could not do any challenge, any of those like that burger. It's like a burger like this big. It's like this big, but it's only like this round, but it's like this long, bro. You have to slice that shit. Huh? Yeah, that's actually kind of big. That's like the size of your fist, bro. Look at that. Look, he had to pick that shit and take bites of it. Come on, bro. You can't just hold on to that shit. You had to pick that shit and take a bite of it. Yeah. How are you supposed to eat 6 of those? Is each one of them $32? Or like.
Yeah, I agree, it's not, not all the time, but.
You have to eat 6 plates of those, bro?
I bet it's a lot of money, so it's right.
Yeah, 6 rolls. I know. That's not one roll. You know, each little piece ain't one roll. That whole plate was one roll. You know that, right? Yeah, cause that shit.
I don't like that.
Dude, I'll give you props if you do that shit, bro. Them dudes had to take like it was like at least 4 bites. It was like 4 or 5 bites.
Not even for a bite, probably one.
Never had a sushi roll that big. It's too close. It was nasty though. Kendrick would like it, but it was that, you know how you like mussels? This I have to watch play for you guys because it was like, oh my god. It was like, I mean, at first it was like, okay. Okay. And then, no. At first it was like,
Yeah.
That's what I do.
read this order, man. They take 6 plates of those. It's one plate. No, I have a hat, so. Get 2 different. If it's just one of those?
No, the whole plate.
Yeah, the whole plate? I got the whole plate in 10 minutes.
No, that's just, you got put away 4 of those, right?
I thought you said put away 6 plates of those. But just one, that's, you just have to eat that? I could do that. That's not a challenge. They would do it, like, that's not a challenge, man. You said that's only one of them, one of those? I know, but one whole plate, yeah. Yeah, because it's only like this big. It's like this big. And then like this big, and there's 8 of those, so. You can do that. Where is it? For real, they all went to the 7?
He did it, though. He did it, that's all.
Yeah, but they're all okay at 7.
I know, I mean, I saw, then by 6:30, rush over there. How far is that away? Not that far, right? There's only like 2.
So 6 o'clock? Yeah. Just tell them when you get back in. We have to go to lunch, Lonnie, I'm sorry.
Okay, let's go some more here.
Sorry, Lonnie, we have to go to lunch right now.
Do you?
Yeah.
Yeah.
Our place closes at 7, you know.
Yeah, we could pick a different place. Our this. So, looks like you guys had your pre-lunch there. Got your cookies eaten. So we get this started here. I'll get you out of here by quarter till. One way or the hell Wheeler's got a new laser cutter. Yeah, I would have never. I would have thought it would have been a bad thing
What is it?
to have Wheeler and a laser in the same place.
It's cutting like.
He's
it's
having
over
fun.
there. It's cutting like
Etching.
composites and
Etching.
stuff like that.
Yeah, etching.
It's not like.
Not only etching, he's gone further now. He's
Oh, yeah.
gone into the world of actually cutting through things
On purpose? Paper.
on purpose.
Mostly paper.
He was screaming at the laser people on the phone. the other day.
He did like the San
He's
Diego
moved on in the world.
Hammer.
Real boy, that's cool.
Him and,
That was actually pretty cool.
him and Pete were having
You
fun
speed
on
it
it
up, slowing it down, increasing power. It's not worth it all day.
40 minutes ago.
Gives me enough light.
That's the only way to live it, man.
Yeah, it was actually pretty cool. So,
Okay, so this is gonna be covered again in the English class, but some of you haven't had this yet. I haven't had my version of it yet. And there are some ignitions questions on the oral, the practical, and the written. No, that's coughing on the cone. Just give you this. Okay, so what are the three main components of the ignition system on a turbo engine aircraft? First one,
Starter.
starter,
Igniter.
starter. Yeah. Ignition system, all right? Somebody else.
Igniter.
Igniter, that's one. Also known as spark plugs. What else?
They have fuels, right?
Have what?
Fuels.
Fuel?
Yeah.
No.
How about a switch?
Switch, that's a mighty
Ignition
small
switch?
part of it. Three major components of this thing. Three major components. Think about it.
Would you be talking about like the igniter box?
Igniter box, okay, so that's two. What connects those two together?
Igniter
The lead. Yeah, so the main three parts of the system are the igniter box, the lead, and the igniter. Now, when you say spark plug around the turbine person, they're gonna know you're a real guy. Because that's what he's talking about, because nobody calls them igniter plugs, right? So you go to stores and you have to get one, and then they're gonna say what part number. So be sure you know what part number you're looking for. But you can call them spark plugs, that's fine. Because that's exactly what they do. They create an arc, which creates the fuel to burn, and then on and on. Now,
They give a good spark too, don't they?
what's that?
They give a real good size arc.
Yeah, it's a pretty vibrant spark.
This
Yeah,
is more of a
It'd
passive
be
spark,
almost-
right?
yeah, you could have a capacitive type discharge spark on a reciprocating engine. Reciprocating engines that have FedEx on them usually have something better than a magneto on them. They're gonna have some electronic ignition system, so it's gonna be a capacitive generator spark.
So I'd almost compare like an igniter to
So an igniter for the main engine, would that be similar to like the igniter for an afterburner?
Could be, yeah, it could be, they're both gonna do the same darn thing. Emissions, I don't wanna go there. Right here. And the reason is, you've got a lot of fuel and air rushing past this thing. You want a good positive method of ignition of the air and the fuel. Once the engine, as you already know, inside the combustion chamber, once the ignition occurs, it's gonna be propagating a lot of heat into the surrounding area, right? Generating a ton of heat into that area. And so once you generate that heat into that area, any air that then subsequently flows into that area, what's gonna happen to the temperature of that air? It's gonna go up, right? It's gonna be carried up. Well, we've already increased the temperature of that air just by compressing it. Okay, so now we add this extra heat to it from the combustion chamber. Do we need to keep any kind of a spark going at that point?
No.
Probably not. Now it depends on the combustion liner. It's a whole range of things that it could depend on, and we're going to talk about those here in just a second. There it is. All right, ignition system. This is a pretty simple system, and every system is going to be just a tiny bit different, possibly. But there are some basic tenets to it. So you have the three basic parts to begin with, and they may look different than one another, but know that you're going to have an igniter that's going to generate the spark. So we don't have any magnetos on these things. You're going to have an igniter which propagates the spark, creates a spark, holds it inside the combustion section, and you've got to have some way to get that spark from the igniter box over to the igniter. So if you haven't already, break those three groups down. Okay, so the only real reason to have this is to start the combustion process. And we're going to use somebody over here that said a starter. Well, we have to have a starter so that we can start moving air through the engine. Because it won't move on its own. There's no other way to get it to move except using a starter. The starter doesn't have anything to do with the ignition itself. Again, once the ignition process is started, we can turn the ignition system off. A lot of smaller aircraft will run with the ignition system on, but it goes to an intermediate stage. What that means is where it may go snap, 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 one right after another. It may only light off every 2 or 3 minutes. It may go snap, 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 and shut itself down. So some of you are in my ignitions classes, and so every time you have an arc occur across a piece of metal, what happens to the surface of the metal?
Metal transfers.
End up with metal transfer, right? Would you guess that? Something happens to that surface. As soon as you move, that voltage jumps from one side to the other. You're going to have some metal transfer that's going to start misshaping that metal. Now it takes an awful long time on an igniter, but it can kill the life on an igniter pretty quickly. So if an igniter is good for, say, 3,500 hours of operation, that's 3,500 hours of operation, not just being flown around the skies for 3,500 hours. If this thing runs constantly, you may cut down the life on that igniter to maybe 500 or 1,000 hours of operation. What's a turbine igniter cost? So they can be all different prices. I'm going to show you a picture of a little dinky glow plug. I'm going to show you a picture of some bigger igniters, and I got a whole box of them here that you can look at later. Point is, they're all different prices, but they are generally start out pretty pricey. So $100 for an igniter is not unheard of. And they'll go all the way up to $1,000. So you don't wanna take any life out of these things if you don't have to. Okay, so we're gonna convert electrical energy from some high energy source to a high intensity electrical discharge. What we're looking for is sparks, arcs and sparks.
How many spark plugs would generally be in a turbine?
Can't say, and the reason for that is because they all use different numbers. So a small engine might only have one, and you can't get in too much trouble on an engine with only one because it isn't going to start. It isn't going to start if the spark plug doesn't work. You could get yourself theoretically into trouble if you had two, because then you could get a false sense of reliability there. So they put one on, so you just can't get the engine started. The second part of your question is most large turbine engines use very reliable igniters, but they'll have two on for redundancy.
So it only starts the flame in one spot and then it'll propagate around the turbine.
Propagates, yeah,
Okay.
throughout the combustion case. Okay, so we're going to use continuous sparking until the engine starts.
Lunchtime.
She gone.
What the hell just happened there?
Did the whole computer turn off?
The backup horn stops, got quiet. What if they're connected to our electrical system?
They're working outside, they cut our line.
We'll switch the laptop. Here we go, we're back.
Did you go back?
Or not. Oh, we got the camera going now. Oops. I think that's where you broke off there. I think that was a little bit. Okay, so when we start the engine, we're cranking it, we want to have a good reliable start. The starter presumably.
Sit down.
You ever have, does this ever happen to Paul?
No.
What you found this morning, Paul, he doesn't like you, I guess.
Yeah, I guess not. Yeah, well, there's a lot of that out there, so that's okay. All right, once we get the combustion initiated, the ignition system is complete. That job is done. It's over. Okay, so it'll be shut down. Now, a lot of aircraft, it can be reinitiated, and it's reinitiated for those two things primarily down at the bottom down there. So in your glossary, IFSD, make yourself a note, in-flight shutdown. It is like the most blood-curdling sound that a maintenance manager can hear. In-flight shutdown. Now that means the engine has been shut down for some reason, either on its own or due to a maintenance failure that the crew recognizes. And it's going to require an engine restart. Another reason you might want to restart the aircraft in flight is precipitation, visible moisture. That includes ice and rain and all of that stuff.
You're talking you can run the ignition system like as a precautionary, or if it goes out
Yeah,
Be
so if you anticipate precip, you can turn the ignition system on.
And you just let it run
Just let it
continuously?
Yeah, it has a secondary mode to it usually.
Okay.
That runs at a slower pace. But if necessary, you just turn it on and leave it run. Won't hurt it a bit. We'll take some life out of the spark plug, but you have a choice between landing the airplane or worrying about a $100 spark plug.
Yeah.
Okay, for restarts, precip and ice, maybe even because the air routes carry airplanes a lot further than they used to, maybe even flight through volcanic ash. The volcanic ash isn't that it's so much abrasive to the engine, it is, but the other part of that is that it will choke air supplies off inside the engine, air sensors, and that will cause the engine to shut down. So you need to have a good, reliable ignition source running during those time frames. Now, they have a lot of different shapes and sizes to them, and they have a lot of different requirements for them depending on the engines. So if you have different combustor designs, what kind of different combustor designs do we have? 3 basic ones, right?
Can.
Annular, right, exactly right. Different performance parameters on the engines. Operating environments, there's some turbine aircraft will only operate below 10,000, 15,000 feet. Some don't really operate hardly to ever at those kind of altitudes. They're operating at 35, 40,000 feet pretty typical, and even higher. The mounting of the system has a lot to do with what kind of equipment gets added to the aircraft. And then there's some different companies that make these parts, and they have different design philosophies. And usually what will happen is Mr. General Electric will go to Mr. Unison, and they'll say, Mr. Unison, I need a system for my engine, and I'm putting it on an Airbus. So Mr. Unison's already done stuff for Airbus, so he kind of knows what they're looking for. He kind of knows what GE is looking for. And so they will cross-design a product that will fit across a number of different platforms. Okay, there's 2 types of energy systems. One is a high-tension system, and one is a low-tension system. Now, these things are capable of putting out 30,000 volts, but they may not start at a higher, at the same threshold. So low tension system, if I remember right, is around 2,000 volts. And a high tension system is going to start out at about 8,000 volts. Sets?
High tension is like 8,000. Low tension.
2,000 for the low and 8,000 for the high. Now, because all of these things now are electronically controlled, they used to have some funny little systems inside the boxes. They were mechanical wheels that would turn. They had points, bridge points. So when the voltage would build up high enough to jump the gap, that's the voltage you got. There were preset levels. At the factory, there was no adjustability for you out in the flight line. If it didn't work, you took it out and put another one in there. It was a set. So now it's all electronically controlled. So on a cold day, would you need a hotter spark, or could you use a cooler spark?
It's more dense, the air, so cooler spark.
Hmm?
The air is more dense, so
Hot day, what
No.
kind of spark? Hotter or cooler?
you could use a hotter spark, right?
Hotter spark on a hotter day, yeah, or a restart maybe. Something that's already been started and requires a little bit of extra budge to get it going. Okay, so the basic components, here they are here. The exciter, or multiple exciters. also known as the ignition exciter. You're gonna have the ignition lead. Or if you have a couple of spark plugs, you might have a couple of ignition leads. And then you have the plug, where you may have 2 or even 3 igniter plugs. And so here's the general arrangement. It's pretty simple. Burn that into your memory, and you won't have any problem knowing what the components are. So here's a couple of igniters down here. Little spark plugs. You have the leads that connect them to the source, ignition exciter. This is called a 2-channel system because it has 2 leads that come out of it. Down on this end is the electrical input, so this is going to be ship's power here. It's going to come from the bus bar and switch for the ignition. Then you've got a few of these little guys here. They go through firewalls and baffles just to make sure that they go through a sealed area. You don't have heat running through there where it's not supposed to go. Okay, the igniter. You got the lead, and you got the ignition exciter box. So the exciter, it can be either airframe or engine mounted. It's usually mounted pretty close to the exciter. And the reason for that is you don't need any leads any longer than they absolutely have to be. Leads do fail, mechanics step on them, pull them, twist them, they get disconnected, they get reconnected. The shorter they are, the longer they're going to last. Okay, so the exciter is airframe or engine mounted close to the igniter lead, to the igniters. It's a sealed unit. That means don't stick your screwdriver inside of that thing.
Not even a little?
What's that?
Not even a little?
Not even a little. You can look at it with the screwdriver in your hand, but don't try breaking any screws or nuts or bolts or seals loose on it. It is a line replaceable unit. An LRU, of which there are thousands of on aircraft today, whether they're small airplanes or they're large airplanes. So just like everything else is throwaway world, you take the LRU off, put the new LRU back on, turn in the old one, typically it gets sent out and gets rebuilt. It goes back into storage. It's going to use power from the aircraft bus or from an engine mounted generator. A lot of times they power these off of a small generator that only puts out just a few amps. And that little generator runs all the time. Really has no wiring to it. It's called a PMA. Welcome to write that down if you want a PMA, permanent magnet alternator. And what it is inside the alternator is spun. There are magnets that are spun very near to a bunch of coils that are inside this little box. And as those magnets are spun past those coils, it generates a small amount of electricity. The reason they use these PMAs on these very large engines is if the FADEC fails for some reason, it still has a power supply to run the ignition unit.
What's PMA again?
Permanent magnet alternator.
Oh.
Now, this is not the only thing that the PMA supports, but know that the PMA also, let's say you lose ship's power to the FADEC, it will also supply adequate power for the FADEC to continue to run. Okay, this is going to convert low voltage to high voltage energy pulses to fire the igniter plug. Pretty simple. So here's a ship's mounted installation. How many channels is this, would you guess?
One.
Single channel, one power wire from the aircraft. You've got the box, it's mounted in this case on a duct, looks like an APU duct. So these things take on all kinds of different appearances, but they all kind of look the same. Typically, you've got a data plate on them that will say ignition exciter, which is going to give you the lead in as to what it really is. Okay, here's another one here. How many channels on this one?
There's
Two channels out.
two.
Power's way down there on the left
The
hand.
other one has, oh, I made one.
The
I had one
ignition box and the exciter are the same thing, right?
Yeah.
Okay.
So that mounts like a power on the other side.
Right. So that's about it's about all the harder it is, really. It's nothing too tricky to it. The guts, that's a different story. But the basic system is the three basic items, and you have to have power to it. So you've got a crack up here in this flange. Okay, so the exciter. The low input power is stored inside the exciter in a capacitor, and then it's released quickly. So if you can imagine a capacitor, and they do a number of different things. Capacitors are built a little bit like storage batteries, and as you fill them electrically, most will get to a point where they won't take anymore. Everything that's in it will tend to go to ground. So if you can imagine filling a bucket with water and then kicking it over, that's where you're going to get your spark. Get this capacitor so full, can't take any more, tips over, sends a voltage down the wire to the exciter, and that's the end of it. Pretty simple. Now, capacitors do quite a number of different things, but in this case, that's what it's for. Now, we used to use what we call the spark gap, and it acted like a capacitor because what would happen is the voltage would build in a wire, and as it got to a certain point, it would have to jump across a couple of points, and at that point, when it got ready to jump, what would happen is it would generate a spark. Voltage would get so high it would jump the gap. Now, that was a little problem because what it would do is it would ionize the inside of the box. When you ionize the inside of the box, you end up with problems like flashover. So you have to be extremely careful with insulation inside the box. Most of these things have gone the way of the Buffalo. There's still some out there, so expect to see them. But know that most everything now is electronically controlled. Like that last section says there. Late generation types use electronic solid state switching for very accurate control of the discharge voltage, energy, the amount of energy is called joules, and the spark rate. So on a hot day, we're going to need a hotter spark. On a really cold morning, we're going to need a really hot spark. But at other times, we may not need that much energy. And if we don't need that much energy, that's going to help to save the igniter and the exciter box.
So you're saying for a hot day or a hot start, you would need a hotter plug?
Yes.
Or a hotter spark? And then, so a cold start, cold day, same thing?
Same thing, yeah.
And then you wouldn't need so much wind?
other times when it's, some of the weather's cooler, or maybe it's a secondary start, but you've got good weather conditions.
Okay.
Anytime the engine tries to overfuel or is susceptible to overfueling, you're gonna want a really hot spark. Phil got that? Yeah. Okay. Okay, so the electrode spark type gaps are gonna be operating 20,000 volts to 30,000 kilovolts. I could probably move that around. It's 20 to 30,000 kilovolts. These operate at pretty low frequencies, and they can be heard prior to starts. So let me see if this will work here. The best place to hear if an igniter is working is because you have a real commotion up in the front of the engine going on with the compressor. The best place to hear it is at the back of the engine. You hear it in the tailpipe because it echoes down the tailpipe. It's my friend from Canada. See if he's still on with us. You can just hear it just before the engine starts.
Sound, the sound's
down,
off in the bottom.
down.
Right. Turn the sound on at the bottom.
See, I gotta hit that with escape. There, they updated this here. Up to south.
Nope, they
No.
never.
There we go. Okay, so it worked that time. Be back to something.
It's like 5 different volumes too fast.
Oh, you gotta hit the thing on behind the screen.
Do what?
Volume adjustment behind your screen on floating.
Oh, the knob. I think it's turned up a little. Oops, let's turn it back so. This thing got it started. Let me back this up. Yeah, really, that's snapping. That's the ignition system. When you start the engine, the ignition system is on. And if it's not on and you decide to throw it on, you gotta have fuel in the air of the engine. You get it with the ignition on it, so you can blow the engine. Okay, one more time, real quick on the igniter. The engine is lit. It'll kind of take a gulp when it finally lights. That's enough of that. Okay? So everybody kind of knows what that sound is now.
What a meter was that?
Yeah, where's that Delta?
A couple of years ago, I marched one in here, and you should have seen the horrified looks, because there were several administrators who saw that thing come in on a truck. And they drove it around the building down here. And I was kind of sizing it up, thinking, that fit? Because we weren't talking about a test cell then. And boy, they came down here in their cars right behind that semi truck. And they're kind of all looking. And I'm out there shaking hands with the guy, we're smiling, gesticulating, you know, and saying it didn't have any kind of tailpipe on it. It was a JT8, because Delta offered to give us a JT8, right? And I know JT8's from one end to the other. And so I thought, this might be a pretty cool thing, but I'm thinking, how am I gonna tie down 27,000 pounds of thrust? And I said, you know, we might be able to run it once a year, because the thing only, you know, when you're burning it on a test cell deal like that, you probably burn 150, 200 gallons of fuel for about that long. But I thought, what an amazing thing, and so they got there was like 4 of them in 2 cars, and they just started walking towards me. And I could see, no, this probably ain't gonna work, so I wish the guy well, gave him a 20 for stopping by, but, and he drove away, and then they never came down to talk, they just turned around and got back in their cars. And later on, about 2 months later, they asked me, and they said, what were you gonna do with that engine? I said, well, that wasn't my engine, I was just shooting the shit with that guy. And it was like a sigh of relief just washed over him. And, but I can tell you that I have my eye on a couple of smaller turbofans. They're ALF 502s. They use them in BA 146 and beyond the internet. And I look up a BA 146. They're pretty good little engines. They're built by Textron, and they make I don't know 18,000 pounds of thrust, which would be enough for us. Probably too much for us, but it's nice little engines. And so so I still have my eye even on another one, and it is a turbofan that was taken off of a Learjet for a mod. And so that's still in the works too. I'm going to retire in a year, and so I'm really trying to wrap up some loose ends. I'm not trying to generate any more work, but if I could put my hooks into a turbofan, maybe we'd have it here. You can count on that. So as soon as I started building a stand for that little recip out there, what were you going to do with that? You know, it's like everything's like a museum around here. I don't like museums so much. I like to have stuff that I can use and have stuff that you guys can use. So that is, why don't we have a turbofan here? We will. We will. Yeah.
Backwards.
Yeah. They're so darn expensive, and they're all rebuildable. So even a crappy one is worth a lot of money. Incidentally, Delta has just decided to give us $25,000 for electrical and for our deposit programs. So know that that's about to happen. And if you can think anything that would be helpful around here for those 2 programs, please pass those on to your instructors, since we're going to be going out and do a little shopping with that money probably by fall. We get money, washes in. Sometimes it gets used on laser cutters, and sometimes we use it on forest. So
Why did we get a laser cutter?
Because they're cool.
we operate under a system of collegiality, and so we all try to get along. Yeah, and so sometimes I just put my head down. Yeah, so
Because we wanted one.
could be an end of nowhere, it could be okay, I don't know, but I never really saw it as something valuable. But we were happy. So let's see, we can do that. Okay, so anytime you run this exciter, you're going to create wear
Actually,
on the exciter unit and the igniters. And again, these things are not cheap. The boxes themselves, those little boxes that I showed you the pictures of, those little boxes are about $3,000 to $5,000 a pop. So if you break one or one quits working, you have to send it out and get it repaired, have another one come back. You don't want to be wearing those things out. This isn't like the military with an inexhaustive supply of money. Anytime you replace this stuff, somebody's got to pay for it. Okay, so the exciter with a solid state function typically anymore builds up an electrical energy release, has additional circuit in it that converts it into a discharge waveform. So we can change the shape of this. It just doesn't go out and spit out a voltage and then have it fall off like a lot of things do. So we can actually have the voltage go up and go down, creates a square waveform, gets to the top, goes to high voltage, and that voltage will linger. So we have some duration on this voltage that runs and creates that arc across that plug. So we don't end up with a spark that just occurs. We can have it go up and linger longer if we want to. And all of that is controlled within the box. And it's been preset or pre-scheduled by the manufacturer of the engine and the ignition system. Okay, so it's then routed through the ignition lead to the igniter plug. Now, what they just did was when they started building waveforms into these, they got a little more efficiency out of the spark plug. So the spark plug would get hot, which helped in the heat transfer across to the air fuel. You could also, instead of having to generate a lot of sparks, you only had to generate one spark, and it would last a longer time, so you'd end up with an arc that would sit there and kind of continue to glow on the end of the spark plug, instead of just creating a spark and then having to run another one back out there. So all of that created a little bit of conservation in the system, so you don't end up wearing the system out so quick. Okay, so that waveform can be modified and controlled. Voltages can be controlled from 2,000 to 20,000 voltage, 20,000 volts. The amperages can be changed. So if you need that hot spark for that hot afternoon or that cold morning, it's going to have a sensor that's attached to it through the FADEC, which is going to tell it to run longer and also have a hotter spark. And also varying combustor designs. So you may have a combustor that runs the gas through it, builds the pressure, it adds air and fuel to it, and it combusts it at one part. You might have combustors that have 2 stages of combustion in it. What that does, that knocks down the nitrous oxides that come out, the emissions that come out, because you're running it on a higher temperature. So all of this can be planned into an igniter box by changing the circuit card. There are quite a lot of igniter boxes out there that look identical to one another, but yet they carry separate part numbers. See where we're at here. When we get down to that picture, we're going to get so much.
I said we've already been down past that.
Yeah, we passed that picture.
Did we?
Yeah.
Wow.
I'm going back.
Yeah. Well,
Someone's
time
got
to eat.
Oh, yeah, Ford's all ready for lunch. Yeah, we've got to be here. Okay, high tension system, let's talk about that for just a second. See where we're at here. Okay, so we'll go as far as the the glow plugs and then we'll go this much. Okay, so high tension systems. That's gonna run from 8,000 volts up. And these are gonna be the ones that are used on most high capacity airplanes. They're gonna be commercial transport type aircraft. These typically have larger combustors in them, and so they need a hotter spark to burn all the air and the fuel inside the combustor. And it's gonna use what they call a surface gap igniter plug. Most of them are surface gap igniter plugs. And the system's usually shut down at higher combustion pressures, and what that does is that saves the spark plug. It saves the erosion on the tip of the spark plug from the heat and also the sparking action. So they're good, as you might suggest, you suspect these systems are heavier than the low tension systems, physically heavier. They can deliver massive sparks from them. Transport category aircraft are moving across the world from one place to another all the time. Long trips, long duration, and so you need a system that's going to be pretty durable. Having said that, these things still do break, but they're still treated like the small systems. They have line replaceable units, so you're going to replace a lead, maybe you replace an igniter box, maybe you replace an igniter. It's just the size of the equipment is going to be quite a bit different. We talked about them already. I can skip this one here. Except it's a low tension system.
A lot less hours on it.
Sorry?
The hours on it are a lot less compared to.
Yeah, they're pretty lightly built systems. Go down to the last two bullet points here. These low tension systems typically can be shut off via electronic engine controls or by the ground. So these are more manually controlled type systems. And also notice that the spark plug life is quite a lot less as well. So anything you can do not to have that plug in operation is going to save you the price of that plug. Okay, so we're going into ignition leads. It's a good place to go get lunch.
Sure.
I want to leave you with one thing here, though. Let me bump this up a couple. So this is what they call a glow plug. This one doesn't spark. This is one we pulled out of our PC6 here. It wasn't working so good.
It's just like a secret light.
That was the question I was going to leave you with. What does that look like? It's like a cigarette lighter.
Our cigarette lighter.
Yeah.
Just
These will run a little bit
light.
hotter. They use an iridium strip in there. But what would you imagine happens with the inevitable coking that occurs across that?
The coating insulates them and they don't get as hot.
They don't get as hot because the coking actually acts like a cloak or a jacket over those wires. And so you end up with a coil that will continually work, but you lose more and more heat as time goes by. What would you guess that costs? It's about this tall.
500 bucks.
$20.
80 bucks.
$1,000.
$1,500 a pop for those guys.
Holy. 19.
For a cigarette lighter?
For a cigarette lighter. So know that when you're dealing with this stuff, you're dealing with some expensive stuff and you need to keep it clean. We didn't realize they were getting so bad, being new to glow plugs. I never fooled around with them much. There's a good reason to use them, but I never lived in Barrow, Alaska for more than 2 weeks at a time, so it didn't really bother me. But how would you get that cleaned up? How would you maintain that area?
Would you take a metal brush and brush it?
Be real careful about that, 'cause that's pretty fragile stuff up in there. You don't wanna do that.
Mouse milk it.
Chemical cleaner?
Maybe.
Mouse milk is a good lubricant.
Is that what you're supposed to use in turbocharger to decoke it?
On shafts, yeah,
Okay.
yeah, what that does, that lubricates it, so it breaks the carbon up.
Oh, okay.
But, you know, the darn thing of it is, easy off oven cleaner, works pretty darn good. Soak it in, and it's the sodium chloride, no, it's hydrogen chloride, I forget what the compound is.
Sodium hydroxide.
What's that?
I think it's sodium hydroxide.
It could be, yeah, sure could be. But it's meant to clean your oven, clean the coke off of your oven. It's gonna do the same thing with that coil, so you have to be really careful you don't get any on you, or it'll burn the heck out of you. So I wanted to leave you with that, but we'll pick that up again next week, won't you? We'll eat some dinner, be back. Be back here at 8 o'clock.